Yeah, can you guys hear me okay? Apparently you can. I just wanted to say that we'll be starting slowly to avoid delays like we had yesterday, because today the schedule is a little bit limited by the last keynote and the beginning of the hackathon. So I don't see many people who signed up for the hackathon. In the audience, but I just wanted to say, like, again, that there will be a hackathon matchmaking meeting during the lunch break. So, those of you who are participating in it, oh, I see one person. Those of you who are participating in it, just don't miss it, okay? Lunch break, you have to talk to Marius and Laura, who's like back there. Right, so anyhow, I should probably start with an anecdote. To start up, open up this day. And the anecdote is that we discovered a mystery yesterday at the dinner table. We discovered a mystery connecting 5 people among the speakers here, including myself. So at the dinner table, it turned out that 5 of the speakers from the conference, which is not like a large, but 5 of us have like Portuguese partners, none of us being Portuguese. And so Sylvia Pan posted it to Twitter yesterday. And and apparently the thread went kind of viral. Because she posted her selfie, and we're like all cheerfully happy. And I didn't realize that this was the connecting factor. But yeah, apparently people couldn't really easily guess what it was. That's connecting us. Anyway, that's it. As I said, we want to avoid delays. So let me introduce the first speaker for today. This is Laura Grimm, a designer, conversational AI expert. And well, I guess she can take over now. Laura?
Thank you so much, Art, for the introduction. Thank you, everybody, for listening to me today. So, okay. Yeah, I'm really, really happy to be here. I'm very excited, but also a bit nervous because, as Art mentioned, I don't have a background in science. So what background do I actually have? Well, I would like to show you. Where? Wait. Okay, so yeah, who am I and what am I actually doing? So this is me, I'm Laura, and I have a background in cognitive linguistics. So I was at TU Berlin, and yeah, I have a master's in cognitive linguistics, and my focus was on spatial cognition. So everything related to, yeah, spatial language relations, how do people talk about space, and my master thesis was about the spatial language of gamers and non-gamers. So I tried to figure out if there are differences in how people talk about virtual worlds depending on being a gamer or not. This gets relevant later, I promise. So now, also me, I left university and I became a very catchy, very easy to remember title, Head of Conversational UX Design and UX Research in a little agency at Berlin called Lautmaler. And so what do we do? As an agency, we provide like the full service about conversational AI. So we work with clients, we realize different projects. So we try to detangle the idea of our clients. We try to understand our users or the future users of the products. And we translate all of this into concepts and specifications, and they're going to be implemented, tested, improved. And yeah, we also do like the whole technical background with cloud integration services and API integrations. I've been talking about conversational AI, but what is it actually that we're doing? So first question, especially in like, the industry, nobody wants to know what could we achieve with this in the first place, but yeah, what is it good for? So it's a different approach than in science. And conversational AI allows us to allow humans to talk to computers and machines. So as natural and as intuitive as possible. So this can be via phone. Probably you all have had this annoying experiences where a voice of the telephone is like, press number 1, 2, 3, or asking you for something. So this is part of it. But also like chatbots, so where you can just enter your questions as natural as it just comes to your mind. But we also have like those personal assistants that will talk to you in your car or via your smart speaker at home, or even, yeah, your fridge. Maybe not this one, this might be a bit outdated, but generally it's possible. So how does it work? I want to give a quick background, very reduced, but as I already said, it's about people talking. So actually, of course, when we have chatbots, it's writing, but here I'm going to focus on the talking aspect. People talk, and of course, we need microphones or whatever to catch the audio signal. And then we translate it via automated speech recognition. So we translate it into text, and this text file string will be sent to the NLU, so the natural language understanding component, which is then it's based on machine learning. So it's just a bucket with hundreds of utterances that tries to map the new input to, it's machine learning, to the data we already have. This will be handed over to a logic where we tell it what to do. Actually, oftentimes when we talk about AI, it's just a huge combination of if-else connections. That's basically it here too. Then, as I already mentioned, we have our API connections. And at the end, we have a speech output, oftentimes with a TTS, those technical voices. But also sometimes we have pre-recorded files that can just be played. So, and when we talk about conversational AI, definition of AI, I know it's not trivial, but when we see it as machine learning, those are actually the only components, so like in our classic conversation interfaces, that have some machine learning. So the rest is still done by people. So we really like script and decide, okay, if this input comes, we're gonna give this output and so on. And now let's talk about the integration in VR. So use cases. Of course, we always ask, what can we do with it? What is it good for? And why we started working with it was, I mean, we're a little agency. We have many projects with clients. So this is something we were working on, like on the side as a little side project. But we were really hooked up because it's super interesting for us to think about, we already have this environment, this VR environment. We know so much. We know where the users are. We are able to know the environment perfectly to get the cues that normally we are missing when we just have a text string. So we start thinking about, okay, what could we do with it? And of course, it can be integrated to almost everything, like gaming and sports application. You can be talking to your trainer directly. In education, you can have like cute avatars the kids can just ask questions to and be like, hey, can you explain this again? Or they have quizzes and they don't have to push buttons or they don't have to read out possible answers. They can just formulate the things how they feel like they want to say it. Healthcare, of course, for training purposes in general. So this was our approach, and we were like, okay, let's just see what it gives. So we started with this idea, and in this case, the interface would actually be enabling the communication with an avatar. So that's like the basic idea, of course. So you have a human, a player, a user, and you have an avatar, and you can just communicate, ask questions, and so on. And maybe you've already been wondering when I talked about how we really structure all of the conversation, what is about large language models? And of course, with the rise of ChatGPT, a lot of things changed. My first question to ChatGPT when I first used it was, I'm a conversation designer for conversational AI. Are you going to replace me? So this was like my very first question. And the answer, it was a very empathetic answer, explaining to me that no, of course, conversation designers are super important, but I should keep up with the technological process to not get irrelevant. So ChatGPT is amazing and gives so many opportunities. And I hope this works with the sound. I will just play out one example here.
Okay, let's go. Hello, sir. I came to town to become an adventurer. I heard this is the place where adventurers hang out. Is that true?
Welcome, young man. That's right. Many adventurers come to this tavern to rest, share stories, and make connections. You came to the right place.
That's great. Can you tell me something about this guy? He looks really impressive. Is that someone I can go on an adventure with?
Oh, that is one of the toughest warriors around. But I'm afraid he wouldn't be interested in teaming up with someone who just started being an adventurer. He's been on many adventures and has earned his experience through blood, sweat, and tears. It takes a lot of skill and experience to match his prowess in battle. You should gain some experience soloing some easy dungeons first before you consider asking someone like him to team up with you.
Oh, I see.
Okay, so this is, so for me, I don't know how it feels for you, but for me, this is really impressive because it was a really long text string that the speaker was actually inputting, and it was just understood. So for us, what I explained later was this NLU components. We often have problems if the strings are shorter or longer than we expect it to be, because yeah, it's machine learning. So if we're not prepared for the input, of course we can't handle it. So ChatGPT or GPT, if we only want to use this component, and other large language models are really enhancing our abilities here. But it also, of course, it has a downside. So for example, we want to control the tone of voice. So this is something that is extremely important for us, because if you have like characters in games or in any VR application, they can be as individual as humans, and of course this also needs to reflect in the language. They have to not only have a different voice, but also choose different words, have different syntax, semantics, so that it doesn't feel flat in the end, and we need to incorporate this. We also have an issue with data preparation and processing, because of course we can't just put for every NPC in any game or any application, just put like all the information into somewhere and then GPT will magically do something. No, we have to prepare it. We have to allow it to really get the information. So this needs to be done via semantic search, LangChain. Here it's marked retrieval is optional. So of course we could just have GPT generate the answers, ChatGPT formulate them, but oftentimes we really still want to control the output, and we don't want to leave it up to nothing. And hallucinations are still a huge problem. If you're using GPT, you might have realized this already, that sometimes it just comes up with weird things, and sometimes it can be even harmful. So there was one of the first chatbots that was available to the public. It was a healthcare application and was taken down after like only days because it gave really harmful tips to the users. So yeah, we still want to be the output in many cases. And I don't know if you've noticed, we have awful latencies. So this is really a big problem. This is not only because of GPT, but because of the whole process I summed up later, because yeah, there's so many different models, so many different cloud applications that the data has to be transferred to, that we do have latencies. And talking about that a bit longer, this struggle is real, because just imagine you want to have a natural conversation, and it's just like, hey, how are you? And then, thank you, good. So this is really completely immersion breaking. And I very much hope that we're going to resolve this at some point, but we're not there yet. So this is a problem we're having, and it leads directly into the uncanny valley, because it just doesn't feel natural anymore. It's just breaking all the immersion, because we are so used to communicate. This is something so natural to us, and we realize, even if we can't name differences or problems in a communication, we just realize them. And yeah, this is something we definitely have, not we as an agency, but the industry needs to solve. And we also have a problem with surrounding noises in VR, because the headphones that are integrated in the headsets oftentimes are not, not filtering the sound well enough. So we tried out an application also at a conference, and there were just people passing by talking, and the Quest 2 headset had huge problems with that. It was really not possible. But as an agency, of course, we try to develop products for customers, so not for headsets that cost like thousands of euros. So we also have to keep this in mind. But after those negative points, let's take a step back. We were talking, or I was talking about the interface as a connection between humans and avatars, so that they can just talk to avatars. But actually, the interface can also be a connection between the humans and the virtual world itself. So not only the characters that exist in the virtual world, but also like the interface, so an interface for the interface, if you will. And here we go back to the spatial relations, because this is something that we really have been thinking about a lot. Spatial relations are, like communication in general, are supernatural to us. We just talk about where we are, what we're doing with our vicinity, and we don't really think about this. So a very simplified example, what would you say the dot and the person in relation? Where is the dot in relation to the person? It's on her left, right. What would you say? Someone? It's in front. Well, another possibility. But if I look at it, I'd be like, oh, okay, yeah, it's at the left. So the dot is at the left of the person. But if I change my perspective and take the person's perspective, of course, the dot is at the right. And it seems so trivial, but of course, if we have those relations in VR and people be like, hey, change the object to my left, we have to know it. We have to know which objects are to the left. And if the person turns around, we also have to make this relation again. So we have to know the person moved. And as I said, it sounds super trivial, but it needs a lot of awareness of the whole environment the people are in, about the person. So where is the person? What are they looking at? How is their personal relation to the virtual world at this moment? And in order to solve this, we had the amazing opportunity to work with students from Universität Würzburg, and they developed, together with us, a toolkit and a protocol where it's able to, it's just a proof of concept so far, but that allows us to connect like our speech components to VR, in this case Unity, and to really address objects and to interact with them. It is situation aware, it's context aware, it is able to resolve ambiguities, but I think the students who mostly worked on it can describe it a lot better.
Select the yellow cube. Change the color to red. Can you show the properties of the blue sphere?
The blue sphere has the following properties. Can be selected, can move.
Move the blue cube up. Move the blue object up.
So yeah, the protocol they've been working on, it's based on what we call interactables. So every object in the virtual world becomes an interactable as long as you want to make it interactable. And then, yeah, you can just assign properties and everything they described, and that helps us to really being able to identify which objects the users are interacting with. We can like highlight objects that can be interacted with. And so this, of course, occurs for objects like that are part of the virtual world, part of the design. But it's so much more. So we have like the context at any time. For this museum use case, for example, this is what I just described. It would be amazing to just, point to objects and be like, hey, what is that? Can you tell me a bit more? You can have like interactive quizzes by, just pointing to the objects. You can move them, change them. We heard about the possibilities of experiencing biochemics yesterday, and then you can just be like, change this, turn it, and you don't have to use the controllers anymore. You can just tell the interface how it should behave. And we can also, like in this context, replace graphic menus. So especially for people who are not as advanced in using VR, because though it's very immersive, very intuitive, we still have those controllers we still need to act with, even if there are now also controller-less interfaces, but still, you can just talk. I mean, we're talking all the time. Why not also use it in VR? And I mean, this is all still in the realm of dreams and possibilities, but at one point, maybe we can even replace human operators. And then we have like the combination. The avatar can be the operator and be talked to, ask questions to, but also it can be taken over like the whole other interface relations and be like, okay, I want to go to the next menu, I want to switch. It's also very helpful with motion sickness. If you just can say, I need to go to the next room, and you just kind of spawn. I get motion sick extremely fast. So in one of our like playing around projects, we also solved this via voice. It was so much easier for me to be in VR and move. Unfortunately, as I said, I'm a design person. So if you have any further questions concerning like the technical aspects here, this is our CTO, Norbert Gocht. The QR code linked to his LinkedIn. So if you have further questions, I can give this to you also later. And thank you so much for having me. As I said, it's a very humbling experience after all those amazing talks yesterday. And I think I'm in time.
You're ahead of time.
Great. So, yes, are there any questions, any things I could elaborate on?
Yeah, so we have like 5 minutes for questions to Laura. Okay, go ahead. We don't have a microphone, but I guess the audience is small enough. So let's talk about that. Yeah.
It's really interesting. And one thing I was thinking about is most of us have focused on VR as visual. And there was some mention of the other senses. And so in this case, there could be a focus on audio. So I'm wondering what you think about using this sort of approach for sort of a audio-only virtual or augmented reality.
I think I need more details.
So for example, people are starting to use smart glasses. And so I could imagine you could have a voice interface where you actually just see through the glasses as normal, but you can speak to it and it can return replies to you, say, as you're navigating.
Oh, yes, of course. I mean, this is something that has been tried also with Google Glasses to integrate the Google Assistant and all of that. So yes, that definitely is like the most valuable use case. If you imagine you have a training scenario, you need to repair something, you put on your AR glasses, it might be color, and they're like, okay, how can I fix this? Repeat, what was the next step? Wait a second, I didn't get that. So yes, of course. So this will, I mean, we're very much not there yet, but to have this supported and actually be like, like having a real human next to you who can see the same things. We talked about that yesterday. Who has the same field of gaze as you, who knows the same things and can just reply to whatever you're asking. This would be like the ideal.
Okay, so Laura, thanks so much. I mean, this is a great talk, and I have like 1,500 questions already. But, so yesterday we were actually told that, given feedback, that it's actually a good idea to shift questions to coffee breaks. I mean, I wasn't really aware of that, but apparently people like it, that it makes conversations more meaningful than at the regular conference. So yeah, so I encourage you all to like just come up to Laura or like any other speaker. I mean, during coffee break, and then we can like then we can discuss like even longer the regular conference thing. So anyhow, since you already, thanks again, and since you already demonstrated, I mean, the use of brain-machine interfaces, I mean, like trying to switch slides, let's move on to the next speaker, Athanasios Vorvopoulos from Instituto Superior Técnico de Lisboa, and one of those people, I mean, protagonists of the viral thread on Twitter yesterday. Anyway, go ahead and see you, man.
I really appreciate the effort of pronouncing my name. All right. So my bioengineering department, University of Lisbon Engineering School, and I'm a researcher on the Institute for System and Robotics. My main area of research was around brain-computer interfaces. And today I'm just going to be showing some prior work we've done on utilizing virtual reality and using some of the good properties of virtual reality on augmenting brain-computer interfaces with applications in rehabilitation, specifically upper limb motor rehabilitation after stroke. So I would like to give some background initially, and I would like to give a short introduction about brain-computer interfaces. And I really like this definition. I think it's currently one of the best definitions about BCI from Wolpau, where BCIs are systems that measure activity from the central nervous system, and they convert it into artificial output that not only replaces, but restores, enhances, supplements, or improves it. Thereby, it change the ongoing interactions between the CNS and its external or internal environment. Now, in rehabilitation, BCIs are used as a way to train the central nervous system instead of just bypassing the central nervous system. And the aim is to reestablish this intention, action, perception loop, providing feedback, and later on, as we're going to see, proprioceptive feedback. And the contingency between the intention and the action or the feedback, we know so far that it can promote actually activity-dependent plasticity, functional recovery, and we know that it can strengthen key motor pathways. One more let's say that we're using in BCI, we're utilizing they're technically motor imagery-based BCIs, and we know that there is neurophysiological rhythmic activities over the sensorimotor cortices that they're modulating imagination of the movement. This motor imagery practice can lead to the modulation of what we call the sensorimotor rhythms, and we know where they actually belong in space, in frequency, and in time. And this is a phenomenon. This is a feature that we actually call event-related desynchronization or synchronization. So this sensorimotor rhythm training, we've seen that it actually correlates with motor recovery. So there's a set of current limitations in BCI use for rehabilitation, and initially and actually in general, BCIs are not very accurate systems or interfaces for extensive training and calibration. And from a recent meta-analysis from my student Tanos Vavlis, actually found that we can see an average, the reported studies with patients so this is two-class classification, motor imagery BCIs used for in stroke patients. They have a median value of 75%. So for a two-class classification problem, 75 is not great. So imagine where you have a patient and they are maybe correct, they're doing mistakes 1/3 of the time. It's not the optimal solution. And surprisingly, they are not also significantly higher or different from motor imagery BCIs from healthy participants. So we see that there's a big gap here. There's a huge limitation, and we usually we might need many sessions of training. So BCI is a type of neurofeedback, and neurofeedback needs training. It's a skill that we can hone, we can practice. But when we're dealing with patients, we don't have let's say, the luxury of training a patient for a month before even entering the intervention with the actual BCI. So long calibration session, of course, they can resolve to it's a mentally exhausting process, which results to user fatigue. And also, there's also many limitations in terms of feedback design. Poorly feedback design might hinder skill acquisition. And this is maybe a typical feedback that is used in motor imagery training, especially in the hospitals. Involves very abstract, like maybe a fixation cross, some directional arrows, or just a bar moving. So our idea is, and the topic of this talk obviously is how we can actually utilize VR and how we can bring it to motor imagery BCI, so we can augment their potential that could be used for rehabilitation. So with VR, what we can do, we can provide embodied feedback. Okay, so we can see an example here. You can replace the physical body with a virtual avatar. So now with the actual BCI controlling a virtual environment, we can actually send the motor and we can have proprioceptive feedback. We can actually try to teach and try to help the patient relearn on the right way. Now in the virtual environment, they can actually perform movements in a controlled manner. They can be guided, specific and repetitive training. And that could also help on avoiding cases of malplasticity. So we try to avoid cases where the patient learns in the wrong way. And so besides the fact that we can provide this embodied feedback to the patient, and now they can control their virtual body, we can also have ecological valid training where hopefully the skills that they learned in the virtual environment can be transferred to the real world. So far, and as we've seen also from previous talk, we know that these elements of increasing embodiment, ecological validity, gamification of the task have shown some important role in rehabilitation. So what we tried to do almost 10 years ago, just to give a bit of a context, if you remember, 10 years ago was the first consumer-focused headset. We have the first Oculus Rift DK1 launching, and we see after that was a huge change in the commercial VR community. So we see that not only the rate of publications have changed after 2023, but also the number of the new headsets exploded. So now we have not only better systems, VR systems, they're lower cost, and we can easily have access to them. So now we can even, like, let's say, democratize VR, and we can put them out to the house or to the clinic. So this was quite important for us. So with the launch of this first commercial VR headset, although the DK1 wasn't commercially available, was mainly for research, we designed a study where we wanted to find maybe what is the impact with this new immersive, at the time, a cool VR headset might have actually an impact on the VR training, or how we can actually augment it. So we took a traditional motor imagery protocol. So in a traditional motor imagery training, you have a fixation cross, you have a directional arrow, you have to think left and right. You have a training session, where in this training session, basically you train both the human and the machine. People try to have a vivid and clear imagery of their body moving, but also you acquire label data. Then you train your classifier, and then you have an online session where the participant is trying to control the feedback with motor imagery alone. So we took exactly the same protocol and we replaced it with a virtual body. So now instead of having the directional arrow, you have a hand moving, and if this is guiding also the visual imagery. So technically we have the motor imagery and the motor observation. And we added also an additional control condition where we mapped the physical hands to the virtual environment, and the person already did the same training that they had to do mentally. They did it physically. So we wanted to see also how far not only we are from an abstract feedback, but also how close we could be from the actual motor execution. And what we actually found was we found consistent differences in all domains. So in terms of the EEG power, also we've seen that the power of the EEG during the motor priming followed in VR, followed by VR feedback, is actually closer to the actual motor execution than the abstract feedback. And quite interestingly, that was reflected also in terms of classification accuracy. We see the same trend in favor of the priming in virtual reality and the virtual reality feedback, which it's really interesting because we see now with the VR feedback, we can actually help the subject evoke more clear features, more specific clear features that then the machine learning layer can discriminate like easier. So we help the machine by only changing the feedback that we deliver to the subject. So then, of course, this comes at the cost of increased workload. That's something to be expected, given that the priming in VR involved also some physical movement. But this was quite initial positive results that we got like almost 10 years ago. So the idea was, and our aim now, we wanted actually to try to design a new VR BCI paradigm that can be used for rehabilitation training. So what we did, we included again, we designed the virtual body. We created a game called Neuro, where not only now we have a sensory integration between the visual, the auditory, and the haptic feedback while they're performing motor imagery training, but we included also ecological, try to increase a little bit the ecological validity by having a real world scenario. And of course, we added some motivational mechanisms. So during training, the subject need to go and capture the flags. So we have scoring, level progression, so on and so forth. So with all these components together, we actually, we only had data from a cohort of healthy participants. Then we did a meta-analysis. We found studies that they used the same processing pipeline, the same feature extraction and feature translation methods for two-class motor imagery BCIs, and we call them the non-VR group. And we actually found significant differences between the performance of the BCI, meaning that only by providing this multimodal feedback in the VR environment, we can actually help already first-time users that they use for the BCI for the first time with only one session of training, like help increase their performance only by delivering feedback in VR. So as a next step, we wanted also to see what is the influence in the actual brain activity. And by brain activity, I mainly mean the sensory motor rhythms, the event-related desynchronization that we try to evoke during training. And actually, this is the work of my student Diogo, where he actually not only tried to compare the brain activity with the abstract condition, as we did before, but he also tried to see maybe what is the optimal configuration. Like we had conditions, we delivered the same feedback on the screen, we compared it on a head-mounted display, then we added haptics, no haptics, and then we compared it with actual motor execution and the abstract feedback. So we had all these different combinations to see maybe what is the optimal configuration for evoking strong and lateralized ERD. So what we be able to see so far is that, of course, haptics plays the major role here. So we can activate maybe broader regions, and we have this sensory motor activation. Nonetheless, we didn't find significant differences between screen and head-mounted VR. So, so the motor observation with a first-person perspective embodied feedback plus the VR yielded the best result in terms of sensory motor rhythm modulation. So what we did next was actually we recruited a group of elderly population, which the target was to age match our stroke control group. So we know that there are age-related differences in physiological responses, the same to EEG. So we wanted to see, okay, let's take a group that actually age matches the people that we're going to be recruiting at the hospital and see what is the actual impact and if results are consistent. And indeed, in fact, in terms of sensory motor rhythms, we see that with the avatar, with the first-person perspective, using Neuro, we help them drive more lateralized and increase desynchronization. And not only that, in terms of the BCI performance, we help them actually to increase BCI performance through the embodied feedback. So again, this is elderly population. Many of them, well, none of them have actually used VR. no experience with technology. The first time they're going to be using this VR BCI training for one session for the first time, and they managed to have more than 10% increase of accuracy only by getting their training delivered through the embodied feedback. And next, we actually wanted to see in a more higher spatial resolution, we performed some brain imaging using fMRI. And inside the scanner, we delivered again the abstract feedback versus the first person perspective embodied feedback. And this is the work of my student João Nunes, where he actually we actually found that we can, although we can still engage primary motor regions in both conditions, with the embodied feedback, we can actually have stronger cortical activation and in many more areas. So this is quite important and interesting. While this is in terms of rehabilitation applications, what we want to have is actually try to recruit as many regions, alternative or additional regions in the brain. So now we see only locations, but if you think about it, if we see it, that could potentially activate more networks. And if we have the ability to activate additional networks in the brain, that could potentially help in rehabilitation to recruit additional or alternative regions from a patient that actually had the lesion. And also, surprisingly, we found regions that they are part of the mirror neuron system, which is also quite important in rehabilitation. So, so far, this is the what we actually found on the impact of the embodied feedback on the sensory motor rhythms, classification accuracy, plus brain imaging. So, although we delivered the embodied feedback and then we assessed maybe the sense of embodiment afterwards, we never manipulated embodiment. We never embodied the participant before they actually do the training. So one of our questions was, if we actually tried to embody the participant before the actual motor imagery training, will it have an actual impact on the performance? So I had my student, Katarina, from Vrije University in Amsterdam, asking that question, where she actually designed this experiment where she had, she took a group where she tried to embody it. So she used the different visual perceptive triggers, visual motor and vibrotactile stimulation, where we matched, where we had correlated movements. We had vibrotactile feedback. We used a mirror in front of the participant, and then we had also the kind of the stimulation like the rubber hard delusion, so we can increase as much as we could the sense of embodiment with a virtual avatar. Next, we had another group, which was the no embodiment group, which again we reversed what we did on the first case, where we had the third person perspective, was the movement was uncorrelated. And also the asynchronous paintbrush stroke was on the opposite hand, and also again totally uncorrelated. And then we took both groups, and they both run this standard motor imagery training on the first person perspective with the avatar. So in terms of manipulation of embodiment, indeed was effective. We used the avatar embodiment questionnaire from Peck and Gonzalez Franco, which was quite recent. And indeed, we could see that we see significant differences between the two groups. So we have between the embodied and the non-embodied group. Both groups felt the same level of presence in VR, which is good. So the manipulation was quite successful. So our hypothesis here was, all right, so we would expect that the group that was actually embodied will actually help them and have better performance during the motor imagery training session. Nonetheless, this is not what we found. So both groups actually showed the same levels of desynchronization of the mu band, and also in terms of classification accuracy, they scored almost the same. Although there were small groups and there wasn't a within study, but between, and so we might have a lot of variability in there. We could say, at least with a set of limitations that we currently have, that embodied feedback during the actual motor imagery training, it doesn't need a prior embodied session. So we can might as well help the subject invoke strong and lateralized sensory motor rhythms and have good BCI performance by just doing embodied training in the BCI without even having to have this embodiment session before. Now, if this is true, that's good news, because also, if you have to move this to the hospital and to the clinic, it will be really difficult to get the patients that they have no active movement, have level of high spasticity or flaccidity, to try to embody them to the virtual avatar before even starting the training. So if we can actually invoke this this sense of embodiment during MI training is quite important. So even by delivering this motor observation, motor imagery with a first-person perspective, it's enough. It's good news for us. All right. So talking about rehabilitation, I will now talk briefly about the first pilot we had with a patient with the same system, with a neuro. And what we did, we designed this intervention protocol where we had fMRI, brain imaging, and clinical skills before and after the intervention. We have 4 weeks of VR BCI training. And after the end of the intervention, we had a follow-up assessment 4 weeks afterwards, where we had again, we assessed the clinical skills and brain imaging. By brain imaging, the patient had to perform motor imagery inside the scanner. So in terms of clinical skills, we were able to see a clinically important difference. So it really increased 9 points of the Fugl-Meyer scale, which is a scale for upper limb motor disability, which is above the clinically important, minimally clinically important difference. So, and the patient managed to sustain the change in the clinical scales. Since it was a case study, we wanted to compare with other studies that they used BCI for rehabilitation. So it's actually the mean change in the clinical skills is above other clinical studies that they use BCI groups and control groups. Now, what we saw in the clinical study was actually reflected in the brain imaging. So here we can see that there's any significant activation during motor imagery before the intervention, but after the VR BCI intervention, we see additional recruitment of primary and supplementary motor regions, and this was also sustained in the follow-up scan, which means we were able to trigger actual changes to the brain, which was a quite important finding. We also have a longitudinal study that actually currently it is taking place, where at the moment we have 20 patients that they did the VR BCI training, and we actually saw a significant increase between pre and post intervention. Actually, this is the work of my student Monica Afonso and the PG student from Spain that we actually acquired the data, Francisco. And in terms of clinical skills, when we compare with other modalities like functional electrical stimulation with the BCI, or robotics, closing the loop with robotics in the BCI, or VR, or hybrid approaches, it could be VR plus functional electrical stimulation, we see that it's quite high. Our findings in terms of the clinical score difference when using the embodied VR with neuro. All right, so in conclusion, and with some take-home messages, we've seen so far a consistent effect of this VR feedback in the sensory motor rhythms. So we saw significant, also we can actually modulate, not only have lower, but also increase modulatory motor rhythms, but also very lateralized. We've seen impact on the BCI performance, which is really interesting, without even touching the machine learning layer. Only by changing what we stimulate to the subject, we can actually achieve higher levels of BCI performance. We help the subject invoke more clear features by guiding them with the VR feedback in first-person perspective. So this is also something quite important to be able to help people generate brain activity and features that are quite important on the actual training that they're doing. So, and help them also hone the skill. And finally, we've seen also this changing also with brain imaging. Okay, so we saw increased many more regions activated during the first-person perspective embodied feedback, and we found also regions that could be playing quite important role for rehabilitation, like the activation of mirror neuron system. It could potentially activate also many more brain networks than the standard motor imagery training. And so we see that this sensory integration of the embodied feedback, including the visual, the audio, and the haptics, yield the best results on motor imagery BCI training. And we saw, although preliminary, and this is something to follow on, that embodied MI training does not require the embodied training in VR does not require prior embodiment phase. So only by delivering this embodied feedback, first-person perspective during training to the subject, this motor imagery plus motor observation is enough, and it doesn't require the subject to be first embodied to the virtual avatar that they need to control. Now, ultimately, the embodied VR BCI training has the potential to drive network recovery in severe cases of stroke patients, as we saw from the latest studies. Nonetheless, we require more data, more proof, and more interventions are actually necessary before we actually ascertain the efficacy of such systems, given a big amount of limitations that currently have. And with this, I would like to acknowledge and current and old colleagues and our funding bodies. And finally, I would like to thank you for your attention. I guess questions can be afterwards. So
we can now proceed with the coffee break. You guys can
Perfect.
keep Thanos up, and thanks, Thanos. This
Right,
was
thanks
a
so
great
much.
talk.
Cheers.
Yeah, so I guess that's it. So we now have a coffee break. After we'll have the first keynote lecture today. There will be Victoria Interrante, and yeah, so we start at 11. Thank you.
invite because I know her research for a while. I've before worked a lot of on spatial perception, and she has done a lot of research on this in spatial perception in VR. And yeah, and yesterday we found out that also with my new research on ethics problems, there's quite some overlap. And so today she's going to talk about, wait, so I have some notes, virtual reality nature immersion for stress reduction and enhanced well-being. And welcome, Victoria Interrante.
Much, Michael. So it's my huge pleasure and honor to be here today with you all. I've enjoyed so much all of the talks from yesterday and also this morning. Like Sylvia, I have a lot of different things that I could have talked about, and I've got about 20 years of experience on spatial perception and virtual environments. But given the theme of the workshop, I thought I should try to talk to you about something that was a little bit more healthcare related. So, with a little bit of embarrassment, I talked to you about this project, which is something that I've been thinking about a lot, working on a little bit, but is far from being mature. And so, I would love to have suggestions from you guys about a lot of the different things I'll be talking about. Okay, so when you say virtual reality and nature, well, let's just start with nature. Ever since the beginning of time, I guess people have been talking about how being outside is good for you. So a lot of evidence that you go outside, it will lead to better health outcomes, including recover from surgery. Roger Ulrich did a study in 1984, looking at patients in the hospital, the ones who had the rooms on one side of the hallway whose windows looked out to nature were discharged sooner and used less pain medication than the patients on the other side of the hall whose windows looked out onto a brick wall. Lots and lots of research after that. Being out in nature has also been linked to reduced anxiety and improved mood and improved cognitive intentional functioning and so on. So lots of benefits for getting outdoors. So where does virtual reality fit in? I mean, I think this is a really, really important question. So I live on a small hobby farm surrounded by 5 acres of trees and fields, and my house is, every wall is covered with glass, and I just look out my windows from any point in my house I can look at and I can see green. I just absolutely love that. We have horses, chickens. My connection with nature is really, really strong. And so why would you ever, I would never, ever, ever say to somebody, like, put on the headset and I would say, put down that electronics and get outside, right? So why am I working in like virtual reality nature? And I think the thing is that sometimes, even though you really want to be outside, you can't. So here's one example. When you go for surgery, I recently donated my kidney, and so I was there in the pre-op, and you're kind of laying, they get you all ready and you have to wait for the doctor, and you just sort of laying there, and then they have a computer monitor on the side of the room, and it's showing you this video of a babbling brook and birds and things like that, just to help sort of set the mood. When people go into chemotherapy, for example, my husband was on dialysis for a long time. You go into the dialysis center and you're there and you've hooked up to this machine, and you just sort of, if you could put on a headset and be, attached to virtual reality and be outdoors in a calming place, it's just a much nicer place to be in psychologically than sitting there like watching a TV or something like that. And so that's short-term situations where nature immersion might be beneficial, but there's also long-term. So for example, the incarcerated, they would love to get out into nature, but we're not going to let them. And so maybe virtual reality people are actually working with bringing virtual reality nature experiences to the incarcerated to try to improve mood and reduce stress and things like that. And then also elderly residents of inner city care homes. It's just, it's difficult to get out, and maybe there's not that much access in the middle of the city to as much nature as people would like. So anyway, it's not that I want to advocate substituting real nature immersion for substituting virtual reality for real nature, but there might be some role for virtual reality. And then, other use cases are also possible, and I'm going to talk about that in a second. So what I wanted to do is sort of outline for you what I've been thinking about in terms of a research agenda. So, I love nature. I do research in virtual reality. How could I take my skill set in VR and apply it to something that means a lot to me emotionally? So first question is, is this a good idea at all? I mean, does VR nature immersion work? If it doesn't work, yeah, let's just move on and do something else. But many experiments have been done that have shown some positive benefit from VR-based nature immersion. And so, I think that the evidence is pretty clear right now that it's something that's at least worth considering. And then, okay, the second thing, once we've passed the sanity check, how do we do it? How do we get the best possible virtual reality nature immersion experience? And people think about this a lot in the real world too. You talk to landscape designers, people who, Paul Gobster spent his entire career trying to think about what are the aspects of nature that are most helpful to enhancing a sense of well-being. And there's all sorts of things you have to think about, like, can you hear the noise of traffic from where you are in the nature, and so on. So in VR, we can do anything. I mean, you can do a little bit. It's inspiring to see what they do at the Landscape Arboretum. You can shape the terrain. You can put in as many plants as you want, whatever plants you want that will live in the climate. In VR we're even less limited because we can do absolutely anything. So we can do absolutely anything. Like, what should we do, and how do we know what we should do? And in order to do that, I think we really have to think about, well, what is it about nature immersion that leads to well-being? If we can understand that, that can inform our choices of how do we design the most optimal types of nature immersion experiences. And then there's a couple of other things that we might think about. And remember last time I said, well, there might be some other possible benefits of VR. I mean, sometimes what like Mel was talking about yesterday, sometimes VR, you can do things in VR that you can't do in the real world. So with nature immersion, what are some things that we might be able to do in VR that could sort of add to the immersive experience? Are there any possibilities there? And then also, as a VR researcher, I'm really fascinated by this place that the VR has in between, like, reality and not reality. And with virtual nature, I think that gives us an opportunity to look at that question a little bit more. Okay, but let's think about going back to the theories of why does immersion in nature lead to well-beings. So one of the original theories is something people call the biophilia hypothesis. So this was formalized by Edward Wilson in a book, 1984 book called Biophilia, but it's really been around since the writings of it's been talked about in literature since the 1800s. And so this is by no means a new idea. The theory is that people have a natural affinity living things. So we're just how you have a cat, it's born, maybe it's taken away from its mother at infancy, it will still grow up and hunt and scratch and do all the things that cats do. And so they're saying that humans are the same way. We're born with these innate affinities or innate behaviors that are just part of our biology. Okay, so that's interesting, but it's not really informative for so how do we design how does this help us design a more effective virtual reality? Or how does this help us design a more effective nature immersion experience? So Roger Ulrich, who I talked about before, came up with something called the stress reduction theory. So again, it's a theory of why and how immersion in nature leads to well-being. If we can understand why and how, then we can understand what makes up the most effective virtual reality nature experience. And so akin to the biophilia hypothesis, this is sort of a hypothesis that's grounded in psychoevolutionary theories. And so Ulrich's theory about nature immersion, it starts with emotion. So he says you go into nature and you have a visceral emotional reaction, and that visceral emotional reaction then leads to like better physiological signals, which then lead and so on to improved states. So the mood comes first, then the sense of relaxation, and then the other improvements in cognitive function and so on. So another theory is the attention restoration theory. I wouldn't want to say these are in conflict. They're just two different theories that have similarities and differences. So attention restoration theory was proposed by Stephen and Rachel Kaplan in the 1980s, and their theory is really interesting because what they say is that when you're out in nature, what they say is that when you're in everyday living, you've got a lot of stresses of your everyday life, and that those are depleting your cognitive and attentional resources. And when you get out in nature, what nature does is it affords these four characteristics of being away, soft fascination, and so on. I'll talk about them on the next slide. But they allow your depleted attentional resources to be renewed. And so you're sort of restoring your mental bandwidth. And why is this an interesting theory to understand? Well, what it does is it gives us something that we can measure. So we can measure mood, according to Ulrich. According to Kaplan, we can measure cognitive functioning, memory, attentional awareness, and so on. Okay, so the Kaplans proposed characteristics of environments that would be important for enabling them to support restoration. So they said that a natural environment will be more restorative to the extent that it allows you to have a feeling of being away. Because what does being away mean? Being away means a break from your everyday experience. So if you're whatever your normal life is, if you get into the outdoors and it feels like something different, a respite, that would be beneficial. So for example, the walk that you do every day might not be as restorative as a walk that makes you feel like you're not like on your way to work, but doing something a little bit different. Second thing is soft fascination. Soft fascination is this is a really, really important point. So what they say is that when you're out in nature, you're doing something like sitting at the beach and you're watching the waves. I was visiting some friends in France, and they have a house that just looks out over the ocean on the north part. And I said, I could just sit here for hours. You could just watch the waves, and they're coming in, they're hitting the rocks. It's just absolutely spellbinding. And so what happens is that you've got this soft fascination. Soft fascination means you're watching. It's interesting, but it's not demanding. So it's not like you're playing Tetris where all antennas are up and you're and it's grabbing your attention hard. It's just something is happening, so you're not bored, but it's not so much that you can't also let your mind wander. The third characteristic that they mention is extensiveness. So this is the idea that you're comfortably immersed in an environment that's vast, but also reassuring. So all these things. So for example, you don't want to be standing alone in the middle of a desert. Yes, it's vast, but it's not reassuring or comforting. You don't want to be like in a cave because yes, it's outdoors, it's nature, but it's not extensive. And then there's compatibility, and this I interpret as what they say is it's feeling one with the environment. But the way I interpret compatibility is it's if I'm standing in a field of weeds, or if I was talking to some people and colleagues in Finland, and they were saying, yeah, when we think about going out in nature, we think about being eaten by 1,000 mosquitoes. And it's like, well, yeah, okay, you're being away, you're fascinated, there's a lot to look at, but it's not compatible. You don't really want to be there being eaten by bugs. Okay, and then furthermore, they want the environments to be yeah, just feeling safe and not needing to worry about anything while you're out there. And then there's, besides the biophilia hypothesis, the stress reduction theory, and the tension restoration theory, there's also these other explanations for the positive benefits that people have seen from nature immersion, and they include cultural affinity with the tradition of the ancestors. There are also learned positive associations. If you have great memories of the beach, you think about going outside, you remember the beach, and so on. But it's also, this is the third one is really interesting to me. So this it sort of gets back to these psychoevolutionary theories, but it explains it in a bit more of a precise way. And so the idea is that when our visual systems develop, they develop to help us get around in the world, they develop to help us get around in the natural world. And so the statistics of the appearance of the natural world are fundamentally different than the statistics of the appearance of the built environment. So in the built environment, you got lots of straight lines. Out in nature, it's very, very rare that you're going to see a perfectly straight line. You've got a lot more horizontal and verticals in the built environment. In fact, these statistics are so they're so prominent that way back, I mean, I don't know, I think about 20 years ago, Antonio Torralba and Aude Oliva wrote a research paper where they took hundreds of thousands of images, and they trained a machine learning algorithm to be able to classify them into nature, natural environment, and built environment. And then they looked at what are the statistics of a natural image and how do they differ from the statistics of the built environment. So so the idea is that our brains evolved to process visual input whose statistics match the statistics of the natural environment, and that when we're processing visual input whose statistics don't match the statistics of the natural environment, it's just a little bit more mentally taxing for us, and that may be an explanation of why people find it more relaxing to be out in nature. So I think that's really interesting, because what it says, I mean, if this is true, it says that you don't maybe necessarily have to reproduce actual living nature. Maybe something that just behaves natural-like would be sufficient. Okay, so so again, I'm thinking about, okay, like a research agenda. What do I want to do to try to figure out how VR can help? So I wanted to start at the beginning by thinking about, how can I categorize the different ways, the different modes of nature immersion. And so there's basically two categories. What I'm seeing is real, direct from my own eyes. What I'm seeing is mediated. So I'm not actually eyeballs to the leaf, but eyeballs to something else, which is then the leaf is onto the camera, and then my eyeballs are onto the camera. That would be mediated. And then there's whether it's like a real living plant or just like a fake plant. So there's so at the top of this hierarchy, there's real views of real live nature. So the views are direct, the nature is real. And again, within this, there's a whole bunch of different possibilities. At the top, walking through a forest, all the way down to just having a bunch of plants inside your house. And the next level is hierarchy are mediated views of real nature. So the idea here would be like a 360 video. You're not there, but what you're seeing is what you would be seeing if you were there. And then that goes all the way down to having a photograph in your living room of a beautiful place. It's not a view out your window to that place, but it's a view that a camera somewhere had to that place. So the third are real views of something that's not real nature. So what would be an example of that? Indoors with a bunch of plastic plants, or indoors with a bunch of sort of non-living nature. Like, and this is still helpful. Like if there's wood, if there's natural rocks, if there's yeah, I mean, things that sort of evoke nature, even though it's not living nature, it still sort of reminds you of nature, and it's a real thing. And then at the very, very bottom, there's what we do in VR. So it's a mediated view. You're looking in the camera at what something else is seeing, and the virtual, what you're looking at is not real either. So top of this hierarchy, you're putting on a headset, completely immersed in this 3D computer generated environment, and then it can go all the way down from there to just looking at a picture that's not a photograph of nature, but just an abstract, maybe a watercolor that evokes something nature-like. Okay. So, like I said before, previous work has shown that that real exposure to previous work has shown that virtual nature can be helpful, but it's also shown that real exposure to real nature is always better than exposure than exposure to mediated exposure to representational nature. So what does that mean? It means that if you have the chance to get outside, get outside. If you can't get outside, there's the poor cousin, which is putting on a headset and seeing nature. But the poor cousin is still better than the alternative, which is doing nothing and having no nature contact. All right, so so let's talk now about some of the work that I've done. All right, so so thinking about what we can do with virtual nature, there's a couple of possibilities. So one possibility is that when we're with virtual nature, it is beneficial because it evokes a memory of a contact with real nature. So this would be simulating these feelings of biophilia. The other possibility is that it could just be, I think that's on the next slide, that it could just sort of evoke this sense of soft fascination. And so in that case, what you're building might not have to be a photorealistic depiction of nature. So why is this important? I'm talking to my students and I'm saying, okay, I want you to build me this virtual nature environment. And they say, well, like how real does it have to be? And I say, as real as possible. But then, it's like, does it really have to be as real as possible? We were talking yesterday about a colleague who built a tree that had the branching structure of an elm and the leaves of a maple, and I was really, really upset because that was an abomination of reality. But most people are quite fine with it because it's a tree. It doesn't have to be like perfect tree. It doesn't have to match a tree that does it or doesn't it? It's you might not even need to show a tree at all. Maybe you could just show a bunch of pulsing lights, and that would be good enough according to the attention restoration theory if it evokes the same statistical responses as exposure to real nature would be. All right, so let me move on to this. So this is my first foray into this this research. And so the question that we wanted to answer in this work is to what extent are the benefits of nature tied to biomass? So the idea here is there are many different ways to get out in nature. What do you mean by nature? So when I say nature, I'm thinking Olympic National Park. I'm thinking trees, grass, like nature that don't necessarily involve plant life. Plant life, then that might help us sort of get more into what's going on with the biophilia hypothesis and the attention restoration hypothesis. So according to the biophilia hypothesis, we gain these benefits of nature because of our natural affinity to living things, which so live plant. For the attention restoration theory, it's just a question of soft fascination and being away and sort of any experience that checks off these boxes, the being away, the soft fascination, extensive, compatible, and so on, might do the trick just as well without needing to have living things in it. So we were gonna poke right at that question of living things. How important are the living things? Okay, so our primary manipulation variable was biomass. So we had between subject design, half of the people, we gave people a stressor task. This is traditional in this line of research. People come into the lab and you make them do a bunch of mental math, you get them stressed, and then you put them in VR and let them relax. And that sort of helps get everybody at the same baseline, because you don't know what people were doing before they came into the lab. Maybe they were already relaxed. Maybe some of them were relaxed and some of them weren't, and so on. So just to put the level playing field, everybody does the stressor task. And then what do we measure? So again, we just looked at prior literature. People were looking at these two surveys of mood. So biophilia hypothesis was, focusing on the mood. So there's the PANOS and the ZIPERS. And then there's a scale that was developed to try to assess the fourth key components from the attention restoration theory, and that's the perceived restorativeness scale developed by Terry Hardig. Okay, so here's I think you're going to see why I'm showing you this later. Whenever you're doing a survey, somebody says, "Oh, here's this survey. Everybody uses it to assess mood," and you're like, "Okay, great. I'm going to use this too." And sometimes, it works. Sometimes it doesn't work. When I, look at these questions, not all of them might necessarily be completely applicable to the question that I'm looking at, which is, how do you feel after you're immersed in virtual nature? But anyway, here they are. This is the ZIPERS survey, just the sense of what people were asked to answer. So we had people answer these questions baseline when they came in. We had them answer them again after they did the stressor task, and then we had them answer them again after they came out of the VR. And then here's the perceived restorativeness survey with the 4, the being away, fascination, coherence, and compatibility. Okay, so what was our hypothesis? My hypothesis was that we would have a greater increase in positive affect after being immersed in the high biomass environment, that we would have a greater decrease in negative affect after immersed in the high biomass environment, and that we'd also have better outcomes on the perceived restorativeness scale. Okay, now you don't want to compare apples to oranges, and so this was really tricky. I told my student, okay, we need these two environments. They have to be equal in every way except for the biomass. So how do you do that? How do you get two environments that are equal in every way except for the biomass? So you can't just take away all the plants, because then you've taken away everything that's interesting to look at. You have to have something else that's interesting to look at. These two places have to be equally attractive. Like, I would want to go on vacation here, and I would also want to take a hike there. Like, if you gave me the choice of both, they would be equally aesthetically pleasing. They'd have equal positive valence. Because you imagine like biomass, here's a bunch of live trees, here's a bunch of dead trees. No, because then you're looking at valence, you're looking at happy alive and negative dead. It has to be, happy plants and happy something that's not plants. And it has to, ideally it would evoke that there would be equal complexity. So when you talk to people in landscape architecture, they say that one of the most important characteristics of an attractive landscape is something that offers a sense of mystery. So that's the idea that you got the path, and it's not just a straight ahead path, it's a winding path. And so you don't really know what might be behind the bend, and it attracts you to come and explore. So that's the sense, the element of mystery. And we wanted both of our environments to have the exact same paths, so people would have the same affordances for discovery along the way. And of course, same light level, right? Because if one's bright, one's dark, then you've got dark is depressing or whatever. So this was really, really tough. So anyway, here's my imagination. This is what I had in my mind. Olympic National Park, full of plants, and Canyonlands, Bryce. This is from the American Southwest. Absolutely, totally gorgeous. So these are photographs of real places, and if I could have made these the virtual environments, that's what I wanted. But we live in the real world, and this is what my student was able to put together. But that's that's fine. So here's the top-down views. You can see they have the same path. Here are the first-person perspective views. We've got a canyon and we've got a forest. All right. So what did we find? We found that, well, our stressor test worked. We a baseline amount of positive mood, and after we made them do mental math, they were higher. That we didn't see an increase in mood according to the PANAS survey after the immersion. And this is actually in line with the findings from a meta survey that's been done of virtual nature, and they find that for virtual reality doesn't give you an increase in positive affect the way that going on in real nature will. We did see an increase in positive affect with the Zyper survey. So this is where I say it's really important to look at these instruments just because everybody uses them. You need to know exactly what it is that they're measuring. Anyways, what Zyper's found an increase in positive affect, but only in the forest and not in the canyon. But when we looked at, how much did the affect change after your immersion, and we compared our two conditions, people got happier in the forest than they did in the canyon, but our study was underpowered. I mean, look at the size of those error bars. We didn't have enough participants, and so we didn't get statistical significance. That's my fault for not insisting on running more people. Okay, so here's with negative affect again. Our stressor task worked. People got grumpier, and then they got better in both conditions. You can see that they got, the bars are in the expected directions. With the green is the forest, the brown is the canyon. Again, oops, sorry. Same thing here, but not. You can see those error bars, they overlap, right? They're too big. There's no statistical significance here. Perceived restorative, same thing. Green is the forest. Brown is the canyon. You can see people got less restored after doing the mental math, more restored after the VR. It looks like that green line is higher than that brown line, but those error bars, they overlap, and so this is not statistically significant. So you remember the absence of a finding is not the finding of an absence. All it means is that we weren't able to substantiate our hypotheses through this experiment. And then we also did sort of a sanity check at the end, thinking about this question of aesthetics. We asked people, because my students from the, she said, well, maybe some people don't like plants, so maybe there's a preference for plants versus not plants. And I was a little bit worried that people might have found the canyon a little bit ugly. So we asked people what they prefer. We showed them the pictures I showed you before, the photographs, then we showed them the virtual. This was between subjects, but afterwards everybody saw the pictures and we asked them, what did you like? And people in the photographs, people liked the green space more than the rock space, and they also liked the virtual reality forest better than the canyon. So how am I doing? Okay, I've got plenty of time. Great. So the next thing we looked at was something that was inspired by some colleagues of mine. And there's a local company in Minneapolis called MindView, and they develop 360-degree virtual reality experiences for the elderly. And they take them to care homes and allow the elderly, to give them a chance to sort of get away from it all. And so I'm thinking like when would you use so VR, when would you use a 3D computer graphics virtual environment over a 360 video virtual environment, and why would you want to use one or the other? And so thinking about that from a really fundamental sense, it's so what are the affordances that these two directions offer? So each one has their advantages and disadvantages. The main disadvantage of 3D computer graphics is we're not there yet with the realism, but we're getting there. But the fundamental disadvantage with the 360 video is that you don't get to choose. What you're seeing is what the cameraman decided to see. You're walking down the path, there's a fork in the path. Cameraman decided to go right. If you want to go to left, I'm sorry, but you're going right. And there's nothing that you can do about that. I mean, at least with the realism in the VR, it's like we have hope. If the cameraman is going right and you want to go left, there is no hope. And so what I wanted to do in this study was to really try to get at that question of how much does it matter that I get to choose where I go versus that I'm just sort of along for the ride. And you can think about, there are arguments both ways. So I tell people about this and they're like, oh yeah, I would much rather sort of like go along for the ride and not have to think about where I'm going. I'm just going to relax. And I'd be like, well, I would really want to know, like, so all right, let's just do an experiment and see this, because the answer can maybe help us decide, should we try to figure out how to make 360 video experiences, more engaging, or should we move on to the looking at the VR? All right. So yeah, and this is my slide where I was talking about this. So one of the I guess we're talking about your question of who's controlling the movement. There's also the question, like, should you move at all? 360 video might be superior to VR if you're just going to be sitting still. I don't know, because there's the head movement thing. I can't rotate my head without also moving my head from side to side, so I get sick in 360 videos. But maybe that can be overcome. But if you've just got the same static thing that you're looking at, how long is that going to keep your attention? And are you going to want to do that like week after week after week? Or, would it, like, I can go to the Arboretum every weekend and walk on the same path, and I'm always seeing something different. But if I'm just sitting in the same spot, maybe that's not as repeatable. So that's the other thing to think about. Okay, but here we're specifically focusing on the question of agency and control. Okay. So here's the passive experience, the kind that you would get with the 360 video. You don't get to choose, how long do I stop and look at the water? How fast should I walk? Which way should I go? But in 360 VR, you can do that. Okay, so we ran a study, and we wanted to tightly control absolutely everything. So what I had the student do, so we decided to do this within subjects to try to get a little bit more experimental statistical power in there. So what she did is she built 2 virtual environments. She's absolutely very talented. You'll see on the next slide how pretty they look. I wanted them to be qualitatively similar, but not the same. So both of them have the same ecosystem, the same type of features, paths, trees, water, etc. But they had to be different so that people didn't feel like they were doing the same thing twice. And so in one of the experiences, we gave people a joystick. It was limited in the speed. They could only go 0.5 meter per second, which is like 1/3 of the normal walking speed, because they didn't want people to get cyber sick. So they could push the joystick and move around. And then for the other half, so one trial was this active, and the other trial was the passive. And so when the passive, what happened is that you got your core movement in VR was dragged around by what a matched person before you had done. So every path was identical. You had one person choose a path, and then somebody else got dragged along that path, and this person got to choose a path, and this other person got dragged along. Okay, and then we had the stressor task ahead of time. And again, we used the PANAS, LIPERS, and PRS, and we looked at cyber sickness scores. And my hypothesis was that we'd see greater benefits in the active experience than the passive experience. And so here are the 2 nature environments developed by my student. I think they're both, the level of, well, won't say anything. I'll let you make your judgments. Anyway, these are the 2 environments, qualitatively similar but not the same. And this is what we found. So we had an increase in positive affect with the stressor task. So we made people do mental math, and they got happier. What the heck is going on here? Okay. So this is our participant population. It was a different student who was running this experiment. He recruited all of his participants through a Chinese language WeChat. And so what happened is the people got in, I'm guessing people who were like, this was a challenging task, but these guys like knocked it out of the park, and they knew it, and they were really proud of themselves. They didn't get stressed. Okay, that was interesting. They actually, so this is right. With the Zypers, there wasn't really any change in positive affect from the stressor task, but they did get happier when they were in the VR. So this is similar to the previous. This is a little bit different. Okay, so here's where where we break it down. What are the questions that we're asking on these these mood surveys? And so what you can see here is the red line is after the stressor task. So you can see, well, people are really high on attentive and concentrating. So is that, I mean, that if you think attentive and concentrating is positive affect, the stressor task gave them that. What do we see here? We see people are high on, they really did well on this math test. But then, when they went into the VR, that's the blue lines. So they were affectionate, playful, pleased, wanted to get further into this situation. Okay, so negative affect in the stressor task made people grumpier according to the questions on the negative affect survey. They got better afterwards, but you can see that everybody's sort of like, there's a floor effect here. People weren't very grumpy coming in. We got them grumpy, and then they came back to being not as grumpy, just like before. And perceived restorativeness, this is what we found. All right, so so what did we find? Because I can go back and look, show these two lines. And so the dark is the active, the light is the passive. And so you can see that there's a little bit of a trend that in the active, people were a little bit more restored than in the passive, but these didn't reach statistical significance. So here's maybe a better way at looking at that. So the dark line, the dark figures are the active, the light figures are the passive. You can sort of see that there were increases for all of the immersion experiences. You can sort of see that the increases looked bigger in the active case, but again, there's a lot of overlap, and with how many people did we have? However many people we had, it wasn't enough. All right, so fortunately, just sanity check, nobody got cybersick. People rated it as, both experiences equivalently interesting. When we asked people to choose, okay, of the two things that you did, which one did you like better? 3/4 went for the active condition and only 1/4 went to the passive. So there are some people who would be just fine to be dragged along, but most people want to be able to choose. And so, that's interesting to keep in mind going forward. Maybe there is a reason to think about developing these 3D computer graphics virtual environments over using a 360 video, because then they give you this affordance for agency, which you don't have when you're doing a passive experience. Okay, the other thing we looked at, I still have time, right? Okay, great. So the other thing we looked at was the realism of the nature immersion. And so this is getting back to, if I'm going to look at a picture of trees, say, I'm in the hospital room, I've got this artwork in front of me, and I want to feel restored by a connection to nature. Does it have to be a photograph, or will I be just as happy with a watercolor? I mean, depends on the subject and everything. But how important is it that the virtual nature be realistic? So this was actually led by my student, she's not my student, so she was the student that I advised over the summer. She went back to Colorado, and I've had a couple of years collaborating now with her and her PhD advisor, Francisco Ortega. So this was work that they did in Colorado with, just me sort of chiming in from Minnesota. All right, so they had 48 people. Again, the stressor and the relaxation. Half of the people did a photorealistic virtual nature immersion, which was this one, and half did the lower realism immersion. And she found higher outcomes in the realistic one than in the non-realistic one, which was sort of interesting. All right. So that cyan line is the realistic environment. And that's the perceived restorativeness. Okay. So, all right. So then this is the last experiment I'm going to tell you about. And this is one where I was thinking of, we started thinking about with virtual reality, we're controlling what you see, we're controlling what you hear. But what we can't control is the smell of the fresh air and the feeling of the breeze and the contact that you get by taking off your shoes and planting them in the ground, planting your feet in the ground. And so we were just curious, how much of the restorativeness that you get from contact with real nature is just not going to happen with VR. And so we designed this experiment where we, so here's the conditions that the VR is not going to be that helpful with you. So we designed this experiment where people were going to see and hear exactly the same things. So they've got the headset on, they've got the noise canceling headphones on that are giving them the sounds of nature. And half of these people are going to be doing this inside, and half of the people are going to be doing this outside. And so the question is then, that what's hitting the eyeballs, what's hitting the ears is the exact same thing in both cases. Both cases, people have this pre-stressor task. This time, we learned our lesson with the mathematical, and so we decided that we're just going to go for the full trier. So people are going to do the fear of public speaking, followed by the math. So hopefully that way we sort of push everybody's buttons in some way. And so everybody does this, either indoors or outdoors. And then we also wanted to have a control condition, and so we had the indoors outdoors where you're seeing the virtual nature, and then we had the indoors outdoors where you're seeing a virtual urban environment. Because in the past, people had found, because we didn't know if we were going to find statistical significance. So let's say we have an indoor, you're wearing the VR headset, outdoor, you're wearing the VR headset, and there's nothing statistically significant. So then what have we learned? Nothing. So we want to, so if we have people before have found that being immersed in an urban environment is less restorative than in a nature environment. So we had a virtual urban environment that where we could compare, virtual urban to virtual nature outside, and virtual urban to virtual nature inside, and then virtual nature and virtual urban across the conditions. And so this is again within subjects. So everybody did everything. They had to come back on 2 different days to be able to do it all. And then we this is another thing that's really, really important to me is I don't want people to guess what we're doing. And so what we had people do is they would show up in one location, like say outdoors. We would show them one of the scenes, like maybe they were outdoors in virtual nature, and then they would go indoors and they would see virtual urban. Then they would come back the next day and they would start say indoors, and they would see this time virtual nature, and they would go outdoors and they would see virtual urban. And so we were sort of mixing it up so that people couldn't guess our hypotheses, because we don't want people to, given that it's mostly subjective report, we don't want people just telling us what they think we want to hear. Okay, so here's our virtual nature environment. Here's our virtual urban environment. It's got a lot of water features, which gave you something interesting to look at. It was raining and the lights were sort of buzzing, and here the wind was blowing and the plants were moving. And here's one of our participants. There she is enjoying it outdoors, and there she is enjoying it in the computer lab. And I can't give you the data because we've only run 4 participants so far, and then it got too cold in Minnesota. And so we're going to have to pick this up in the spring. But anyway, I've got a lot of future research that I'm interested in looking at. I'm really, really interested in this question of the reality of the nature. And so I want to bring people into an office with real plants, an office with plastic plants, and in VR, I want to see, like in VR, are the plants real? Are they plastic? Does it depend on how you've been primed to think about them? Like in the real world, there's a difference between real plants and fake plants. In VR, is there a difference between real plants and fake plants? I don't know, but I think that would help me understand something more about virtual reality and where it sits between reality and not reality. Aesthetics, I think this is really important. I think we really need to control for aesthetics because, we don't know, is it people just like being in nature, or do people just like being someplace prettier? So we've got some plans. With that, I talked about the technology with the video and the graphics, stationary versus moving. I think probably it's going to be better to let people move. And then this is the team of people that I've been working with, Francisco and all the great students. So yeah, not so much a keynote, but hopefully you guys got some value out of it. It relates to well-being, and I'd be happy to have more discussions with people afterwards about this.
Thank you for the wonderful keynote. I think we stick to the protocol questions, just not on stage, but in the break. And see you at 1. Have a good lunch.